Interceptors are key implementation of AOP, a paradigm that allows you to inject logic into existing code without modifying it directly. This is perfect for handling cross-cutting concerns, tasks like logging, caching, or performance monitoring that applying to many different parts of your application but aren't part of the actual business logic. Think of an interceptor to slice of bread, wrapping the meat, your route controller, the before phase logic that runs before the request reach your controller, the after phase logic that runs after the controller finishes, allowing you to transform the response or log the final execution time. Next, we implement a response interceptor to standardize our API output and handle logging. This allows us to transform the data stream before it reaches the client. Start by creating a request response.interceptor.ts. We import the core interceptor utility from NestJS command. Along with observable and the map operator from RxJS to handle the asynchronous data stream. We define a response interceptor class that implements the NestJS Interceptor interface. The core of the class is the intercept method, which provides two essential arguments: execution context. This allows us to access the underlying request object, headers, and the controller metadata. CallHandler. This interface provides the handle method. Invoking handle is critical as it triggers the route handler logic and return an RxJS observable. To access the request context, you can use context.switch to http.getRequest method. To modify the outgoing response, we use the path method on the next.handle stream. Inside, we apply the map operator to wrap our response data within a consistent payload property. We can also execute logic both before and after the controller execution. By placing a log before next.handle, we track the incoming request. By placing logic inside the pipe block, we track the outgoing response. This provides a clean way to integrate a logging service without cluttering our business logic. This interceptor ensures that every response from our server follows a unified structure, improving the predictability of our API for front-end consumer. To activate the interceptor, we must import it into our controller and apply it via the use interceptor decorator. However, to truly understand this impact, let's first observe the default API behavior. We start by testing our endpoint in Postman without the interceptor. Take note of the raw JSON response and the console output. Currently, the data is returned exactly as defined in our route handler, with no additional logging or transformation. Once we establish this baseline, we layer on the used interceptor response interceptor decorator by rerunning the same request. You'll be able to compare the results side by side. Pay attention to two key changes. Response structure. Notice how the response body is now encapsulated within the payload object. Execution log. Check the terminal to see your before and after log. We confirm that the interceptor successfully wrapped the request response lifecycle. This comparison clearly demonstrates how interceptor can globally transform your API output without modifying the underlying business logic. Remember, while we apply this to a single controller today, you can also register interceptor globally to ensure every single endpoint in your application follow the same standardized response structure. The service analogy makes interceptor so much easier to visualize. If you were building a production app today, what extra slide would you add to your interceptor sandwich, caching, logging, or maybe custom error handling? Let me know in the comment. If the explanation of NestJS Interceptor helped you level up your backend skill, make sure to hit the like button and subscribe to the channel.